This video will cover the material in Chapter 23, Section C on factorial notation. Let's quickly revisit the concepts that we learned in the previous section when we looked at permutations. Remember that if we want to find all the different permutations of four symbols or four letters like A, B, C, and D, I can draw four boxes, and in each box I can write how many different choices I have for that space. So for the first box I have 4 symbols, for the second box 3 symbols, 2 and 1. And if I multiply all of those together using the product principle, I get 24 different permutations. We often see products like 4 times 3 times 2 times 1. A few more examples: if we have 5 times 4 times 3 times 2 times 1, or if we have 11 times 10 times 9 times 8. We can use something called factorial notation to help us quickly calculate what these products are. And factorial notation has a special notation. So for the first problem, or the first example that I've showed you, this would be represented as 5 with an exclamation point following it. And this is factorial notation. And I'll show you in a moment in one of the example problems how we can write 11 times 10 times 9 times 8 in factorial notation. We can't right now because, as you'll notice, we're not multiplying all the way down to 1. So a few definitions here. Factorial numbers can be written in general form for any number n which is greater than or equal to 1. So I can't take the factorial of 0. Well, actually I can. I'll show you what it is in just a minute. And what this notation represents is for any number n greater than or equal to 1, n factorial is the product of the first n positive integers. Integers being 1, 2, 3, 4, 5, 6, 7, all the way up. In equation form, n factorial looks like this. I'm going to multiply n by n minus 1 by n minus 2 until I get down to the bottom integers, like positive integers like 3, 2, and 1. And again, this symbol right here, n with the exclamation point, is read as n factorial. Now, this helps us define the factorial rule, which is stated as n factorial equals n times n minus 1 factorial. Let me give you an example. If I tell you to calculate 6 factorial, you're going to multiply 6 times 5 times 4 times 3 times 2 times 1. But I can also write that as 6 times 5 factorial. Notice that n minus 1 is 5 in this case. I could also therefore write this as 6 times 5 times 4 factorial, and so on and so forth. This becomes useful when we're trying to simplify expressions later on, and we'll cover that in one of the example problems. I told you that we could take 0 factorial. Using the factorial rule, let's take a look at 1 factorial. So 1 factorial, using the factorial rule, would be the same thing as 1 times n minus 1 factorial. Well, in this case, n is 1. So really, I'm looking at 1 times 0 factorial. Now, we define 1 factorial as equaling 1. So in this is one of those weird mathematical contradictions. 0 factorial, therefore, must also equal 1. So that this first equation holds true. So keep that in mind as you're simplifying expressions. 0 factorial is really equal to 1. Okay, let's do a few example problems. The first one is how to write a product like 11 times 10 times 9 times 8 using factorial notation. Notice that I'm not multiplying all the way down to the integers 3, 2, and 1. So I can't write this as 11 factorial. This does not equal 11 factorial. 11 factorial would be 11 times 10 times 9 times 8 times 7 times 6 all the way down to 1. However, I can rewrite this in terms of factorial expressions. Take a look at this. I have 11 times 10 times 9 times 8. This is my original expression. Then, if I multiply by the remaining integers, 7, 6, 5, 4, 3, 2, and 1, we can turn that into 11 factorial. But that would change the original expression. So, in order to balance this out, I need to divide by the same numbers. 7 times 6 times 5 times 4 times 3 times 2 times 1. Notice I can break these up into chunks. And actually, I'm going to look at the top numerator as a whole, as one chunk. The top numerator, or the numerator, would be 11 factorial, because I'm multiplying all of the integers from 11 to 1. The denominator would be 7 factorial. So this expression right here is equal to our original expression of 11 times 10 times 9 times 8. Now, for those of you who have TI 83 and 84 calculators, the factorial button is included in your calculator. It's in the math catalog, which is, if you just press the math button, which is on the top left side of your calculator, and then it's in the sub catalog of probability. You'll see PROV, and you can go in and find the exclamation point and calculate factorials in your calculator. I can show you how to do that in class. All right, let's look at our last example problem. I'm looking at an expression here where I have several factorial terms, and I want to simplify this. So keeping in mind, using the factorial rule, I can change this original 6 factorial to 6 times 5 factorial, right? It's the same thing. And then I can write the remainder of the original expression. Notice that in the numerator, each term has a 5 factorial. I can factor those 5 factorials out, and I'm left with 6 minus 1 on the inside of my parentheses, and this is all over 5. Well, notice that 6 minus 1 is 5, 5 divided by 5 is 1, and so I'm left with 5 factorial. And again, we'll practice more of these in class tomorrow.